Hello Year 7s, in this lesson we're going to be learning about squares and square roots. Our learning goals are to identify and calculate square numbers and to calculate simple square roots. Let's begin by doing a bit of revision. So in our last lesson we learnt about powers. So I would like you to pause the video and see if you can answer these questions for yourself. How did you go? Let's answer them together now. So write in index form 3 times 3 times 3 times 3. So that means it's going to be 3 raised to the power of 4. The reason why it's 4 is because I have 1, 2, 3, 4 numbers there. Next, I need to write in expanded form 3 raised to the power of 3. So that's going to be 3 times 3 times 3. There's 3 of them because I've been raised to the power of 3. Next, I need to evaluate 3 raised to the power of 2. Evaluate just means gives you your final answer in a basic numeral, meaning just answer it. So 3 raised to the power of 2, that's 3 times 3, which is 9. So your answer should be 9. Hopefully you did well with those 3 questions. So let's now move on to today's topic. In today's lesson, we're learning about squares and square roots. And what we're going to learn is that squares and square roots are inverse operations. Now, you've actually seen inverse operations before. For instance, addition and subtraction are inverse operations, meaning that they undo each other. They're opposites to each other. So too with multiplication and division. They undo each other. And finally, we're going to learn that squares and square roots follow the same principle. They are inverse operations. So it's like you're gaining another tool to your belt today. So let me give you an example of how addition and subtraction and multiplication and division and how squaring and square rooting are all inverse operations. Let's begin with addition. So if I start with 3 and then I plus 1 to it, I'm going to get an answer of 4. If I was to now do the opposite thing, meaning I'm going to start with 4, but instead of plusing 1, I'm going to do the opposite, meaning I'm going to subtract 1, which means I'm going to get 3 as my answer. So notice by undoing it, I arrived back to where I started with this 3. And that's because plus and subtraction are inverse, they're opposites. Multiplication is the same. Let's start with 3 again. And this time, I'm going to times it by 4. 3 times 4 is 12. Now I'm going to do the opposite. So instead of timesing or multiplying, I'm now going to divide. So I'm going to have 12. I'm going to divide by 4 because the opposite of timesing by 4 is dividing by 4. And that's going to give me an answer of, well, 12 divided by 4, it goes in 3 times. And look at that, I arrived back to where I started. It undid it. Today we're going to be learning what squaring and square rooting is. Let me give a bit of a teaser. When we say square, what we mean is, let's start with the number 3, and we're going to raise it by the power of 2. That is what squaring is. And we know that 3 raised to the power of 2 is 9. When we square root, we're going to begin with our final bit there, and now we're going to do the opposite of squaring, which is square rooting, this fancy symbol right there. And the square root of 9 is going to be 3. It's going to take us back to where we started. So now we're really going to delve into what this squaring and square rooting is all about. So let's begin with what squaring is. Let's come here. So squares. To square a number is to multiply it by itself. It's the same as raising the number to the power of 2. So let's come and look at this one. So this is 4 raised to the power of 2. In the worded form, as soon as I see this, I think that's 4 squared, which is 4 times 4, which equals 16. Let's look at this one. This is 7 raised to the power of 2, and we would say that this is 7 squared. So 7 times 7 is 49. So this is what squaring is all about. A square is a number. To square a number is to multiply it by itself. It is the same as raising the number to the power of 2. Let's now come and look at square rooting. To square root a number is the opposite of squaring it. And the symbol for square rooting is this right here. This is our square root symbol. So let's come and look at one. let's look at this. So to say this, you would say this is the square root of 4. And what it's telling me, it's saying what number, when times by itself, is going to give me 4. And the answer is 2, because 2 times 2 is 4. Let's look at this one. This is the square root of 16. And what it's saying, this symbol is talking to you. And the symbol is saying what number, when times by itself, is going to give me 16. And the answer is 4, because 4 times 4 is 16. Perfect. Let's delve even deeper into this. So let's begin with squares. So I'm going to say I have 4, then I'm going to have this 2 here. It's going to equal something. So I have 4 squared. Now, if this 2 could talk, this is what it would be saying. It's saying, what number do I get when I multiply 4 by itself? And we know what that's going to be. That is going to be 16. Let's also take note of some terminology. We know that this right here is my base. We know that this is the power. And we could say this is my answer. So this power, this square, is saying what number do I get when I multiply 4 by itself? And my answer is 16. Let's now do the inverse operation, which is square rooting. So this time I'm going to begin with my answer, and I'm going to use this fancy symbol right here. And this fancy symbol is telling me this. What number, when multiplied by itself, gives me 16? I really want you to appreciate how this sentence and this sentence are just opposite of one another. So in other words, it's saying what number, when multiplied by itself, is 16. It's saying, hey, what's the base going to be? What's the base going to be? So we know that 4 times 4 is 16. So my answer is going to be 4. The square root of 16 is going to be equal to 4, because 4 times 4 is 16. Perfect. Now you might be asking, why are they called squares? Why squares? Where are the squares coming from? Isn't that a shape? What does that have to do with what we're doing here? But why do we call them square numbers? To take a square of a side length of 5 centimeters. So here's our square. It has a side length of 5 centimeters. And as you can see, a square with a side length of 5 has an area of 25. Or we could say that the square of 5 is 25. Hopefully that makes it clear as to why we call it squares. Because a square of 5 will be 25. Let's go through this a bit more. So here I am going to perform a square operation. So here I have a square of 10 meters. So that means to find the area is going to be 10 raised to the power of 2, which is just 10 times 10, which is 100. So my area will be 100 meters squared. But let's now work in reverse. Let's say they gave you the area and said, can you figure out what the side length is going to be? Well, to do that, I'm going to do a square root. The square root of 64 is going to be 8. So 8 times 8 is 64 and meters squared, so I can put a meters here if I really wanted to. So hopefully you can see how they're opposite to one another and why we call them squares. Now, what happens when the number you're trying to square root isn't a square number? So for instance, the square root of 20. What number, when multiplied by itself, equals 20? Well, if you get out your calculator and you try this, what you're going to see is that it isn't a whole number. Rather, we get 4.4721. The fact that we aren't getting a whole number tells us that 20 isn't a square number. So, pause the video and list the first 8 square numbers. How did you go? Hopefully you got these answers right here. And the reason why these are square numbers is because when we square root them, we get out a whole number. So the square root of 4 equals 2. The square root of 9 equals 3. The square root of 16 equals 4. They're whole numbers. I'm not getting any decimal places. So these are what we call square numbers. When we square root them, we get out whole numbers. And also remember, they're squared because when I go 5 times 5, I'm going to get 25. Perfect. Let's now do some questions you're likely to face in the textbook. So let's evaluate the following. 9 raised to the power of 2. Well, that's 9 squared. So it's going to be 9 times 9, which is 81. Next, 3 squared. Well, we know that that's 3 raised to the power of 2, which is the same as 3 times 3, which is the same as 9. Here we have the square root of 144. So what that is saying is what number, when times by itself, is going to give me 144. And we know that the answer is going to be 12, because 12 times 12 is 144. Next, 7 squared plus 3 squared. Well, 7 squared is 49, and 3 squared is 9. 49 plus 9 is equal to 58. Next, 6 squared plus the square root of 121 minus 4 squared. 6 squared is 36. This is saying what number, when times by itself, gives me 121. The answer is 11, because 11 times 11 is 121. Then we're going to subtract 4 squared, which is 4 times 4, which is 16. 36 plus 11, well, that's going to be 47. And now I'm going to subtract 16 from that, which is going to give me 31. So my answer will be 31. So let me put a box around each of my answers. When you're in a test, please put boxes around your answers. It makes our lives as teachers so much easier. Hopefully this lesson was helpful to you. Let's recap what we learned. So what did we learn today? That a root is the inverse operation of powers, also known as exponents. We learned how to identify and calculate square numbers, and how to calculate simple square roots. Hopefully this was helpful. If you struggle with any of it, please let your teacher know. And please now complete the allocated work during this lesson.